Starting the Hubless motorcycle build project. The mechanic selects old recycled car rims. A reinforced steel tube is fed into a 3-roll bending machine. The continuous pressing roller system bends the steel blank. A chain drive combined with an electric motor provides progressive compression force to gradually increase the bending radius. A close-up shot details the plastic deformation, as the straight steel tube is bent into a perfect circular arc. The rolling process ends when the two ends meet. The shaped steel ring is removed from the rolling machine. Precisely cutting and aligning the connection point. Then using TIG welding to melt the metal and securely tack weld the joint. An angle grinder is used to grind down the raised weld seams. A section of an old bicycle tire is cut open. The elastic rubber layer tightly wraps the outer edge of the steel rim, using a cordless drill and self-tapping screws to anchor it firmly. The next step is machining the load-bearing roller mechanism from a solid block of engineering plastic. Carefully marking lines and using a handsaw to cut a blank section. A preliminary check of the bearing's outer diameter. Clamping the blank in a vise, using a wide spade drill bit to hollow out the center and create space for the support bearings. A highly innovative homemade lathe setup using a threaded shaft and a hand drill chuck as a high-speed spindle. An angle grinder disc acts as a lathe tool to remove material, carving out a smooth, U-shaped concave groove profile. Fine sandpaper is applied to polish the machine surface, finishing by pressing the bearings into both ends of the roller. 3 drive roller assemblies are completed.
Rounding the concave groove to perfectly match the rubber tire surface on the rim. Proceeding to fabricate the mechanical mounts for the rollers, using a tri-square to precisely locate holes on the steel plate. Placing the blank on the drill press to punch pilot holes, machining and expanding them into linear sliding slots. A nut is arc welded directly onto a sliding base, setting up a lead screw mechanism for flexible tension adjustment. The steel plate is hydraulically bent into a load-bearing U-bracket, assembling the roller with a central axle bolt, tightening the axle bolt to lock the roller securely into the U-bracket. The 3 independent drive assemblies are ready, shaping the machine. Fitting the wheel ring into the 3 support points on the wooden jig, perfectly aligning the center axis to ensure even force distribution.
Gradually takes shape, becoming extremely rigid. Completely encloses the wheel's rotation path. The heart of the machine appears. A horizontal cylinder internal combustion engine. TIG welding the roller mounts securely to the inner rim frame. The melting arc creates a permanent and stable bond. Kinematic testing. Rolling friction is perfectly optimized by the bearing system. Moving on to the chassis. Rectangular steel box tubes are chamfer cut and welded. Test fitting. The skeletal frame inside the main wheel cage. The engineer begins welding the space frames, load-bearing tubes together. The multi-dimensional spatial structure.
Measuring and obtaining precise coordinates for the engine mounts. Machining. The steel base plate on a specialized drill press. Precisely drilling 4 holes to mount the engine block bolts. Positioning the engine block onto the bottom rail of the frame base. Welding the steel base plate to the structural tubular frame, then moving to the transmission assembly. a standard chain, and a steel flange blank, carefully marking the hole centers, preparing for the drilling and tapping operations. Drilling and tapping threaded holes on the spacer flange face with a drill press. Mechanical precision determines the concentricity of the drivetrain. Screwing the spacer flange securely into the vise to machine the flange face. A hand drill continues to ream the threaded holes on the locating surface.
Inserting the spacer flange into the galvanized hollow steel shaft, using TIG welding to completely seal the flange to the shaft. Assembling the sprocket onto the newly welded flange unit, tightening the bolts to secure the sprocket for the secondary drive. Integrating the sprocket assembly with a load-bearing support roller, inserting the steel shaft through the roller core, and locking it tightly with a retaining flange. Using a hex key to tighten the set screws, securely pressing the retaining flange onto the shaft core. The complete idler sprocket pulley assembly is ready. To transfer the torque, assembling the large sprocket. To the opposite side of the drive roller, press the bearing into the steel bushing, preparing to fabricate the swing arm pivot shaft. Tack weld the bearing cup to the end of the square steel tube, to create a moving hinge joint for the rear swing arm. Continue marking and drilling holes on the sliding slot of the flat steel plate, using a high-speed drill press. Fully assemble the parallel swing arm system, combining the multi-belt, drive, pulley, shaft, and brake disc. Insert the swing arm assembly, integrating the drive roller into the main frame. Adjust the angle and weld the mounting bracket in place. Route the heavy-duty drive chain, connecting the engine's small sprocket to the intermediate sprocket on the swing arm pivot. Install the single coilover shock absorber, connecting the main frame and the rear swing arm system. Step 4. Insert the hydraulic brake caliper into the steel brake disc mounting bracket. Step 5. Arc weld the mounting pins to secure the brake caliper to the swing arm, completing the speed deceleration system. Step 6. Use a hand drill and self-drilling screws to securely fasten the leather-wrapped seat to the frame. Step 7. Start fabricating a custom exhaust. Step 8. Fabricate a flat steel mounting bracket and bearing assembly. Assemble the muffler to the engine exhaust header, ensuring a completely airtight seal. Weld the mounting brackets to secure the exhaust to the chassis, eliminating vibrations when the engine is running. Introducing a crucial mechanical component, the blue powder-coated universal joint. Integrating the universal joint into the steering system allows rotary motion to be transmitted through flexible tilt angles. Selecting scrap materials from an old tire yard, picking out 2 rusty steel rims for the front wheel hubs. Clamp the rims onto the cutting table, and use an angle grinder equipped with a heavy-duty cutting disc to remove the center hub. Use a sledgehammer to knock out the excess core. A flap disc is used to grind down and flatten any rough edges. The old U-shaped rim surface is thoroughly polished, fully restoring the smooth, shiny steel finish. Accurately measure the rim's radius, and use a compass to draw 2 concentric circles on a thick, flat steel plate. Use a handheld cutter, following the drawn lines, to cut out a perfectly shaped steel ring. Chamfer the edges of the steel ring. Use an angle square to divide the circle into equal segments and mark them with a marker. Test fit 6 small bearings onto the marked points to ensure an even load distribution. Step 1. Secure the steel ring onto the drill press table and drill through to create 6 mounting holes. Step 2. Use an angle grinder to cut open U-shaped slots at each drilled hole, preparing for the bolt mounting brackets. Step 3. Once the U-shaped slots are complete, the engineer inserts the mounting bolts and TIG welds them, securing the bolt bases to the steel ring. Each weld is ground smooth using an angle grinder, to ensure a perfectly flat mating surface. Hang the 2 steel rings on a powder coating rack and apply a protective blue coat to prevent corrosion. Stack the nuts, washers, and bearings onto the threaded shaft to form a side clamping guide roller assembly. Arrange the 6 bearing roller assemblies into the 2 blue rings, setting up a dual concentric sliding clamp system. The guide frame tightly clamps into the yellow painted rims groove. The hubless front wheel mechanism has established its core principle. Mount a light-duty car tire onto the U-shaped rim assembly, and push the 2 hubless front wheel assemblies into alignment. Step 3. Fabricate the wheel clamping brackets. A steel plate is bent into a U-shape and marked with coordinates, preparing to drill and cut for mounting points. The drill press punches through the thick steel to create 2 symmetrical holes for inserting the locking shaft of the front suspension mechanism. Loosely attach the standby bolts to the 2 walls of the U-bracket to accurately position the inner clearance. Press 2 roller bearings into a short steel tube core to create a pressure roller that rests directly on the tire's friction surface. Mark the pivot axis on a flat steel bar. Use a drill press to bore a hole and install a pivot pin for the load-bearing arm. TIG weld the H-arm to the steel roller housing, securing the sliding bracket to create elastic suspension travel. Assemble the roller arm onto the U-shaped base. The suspension clamp mechanism is ready to fully grip the tire surface. Mount the U-bracket directly onto the front wheel hub. Use arc welding to tack and secure the independent suspension system. Carefully measuring the clearance of the A-arms. Inserting the bent steel bars to form a load-bearing steering bridge. Welding the front fork frame firmly to the central engine mount, firmly connecting the steering shaft to the dual steering box wheel assembly. Measuring the dimensions of the steering edge, drilling holes in the steel billet to create mechanical steering joints. Installing the bright orange painted steering edge.
Fastening the bolts to lock the dual-action Ackerman steering mechanism. Attaching the straight handlebar to the steering universal joint. Completing the direct steering system for the 3-wheeled machine. Setting up the electrical system and control cables. Routing the steel braided throttle and brake cables along the frame. The teardrop fuel tank is mounted right on the backbone frame, connecting the fuel line to the carburetor. Checking the ignition and pull starting the engine. The exhaust growls powerfully, and the engine RPM is stable. Finishing the overall matte black powder coat on the frame to highlight the galvanized mechanical details. Leo, the hubless 3-wheeled machine proudly rolls out of the workshop. The drive roller system runs smoothly without any squeaking. Starting the field test.
The engineer twists the throttle, the clutch engages, and the machine surges forward. A close-up shot shows the 2 front hubless wheels spinning fast. The Ackerman steering system works perfectly during sharp turns. The rear wheel's friction drive proves its absolute efficiency. There's no slipping, even with a sudden spike in torque. The rear coilover shock and front swing arms absorb impacts, keeping the chassis extremely balanced on rough roads. Accelerating to maximum speed on a straight stretch, the engine roars, demonstrating incredible mechanical stability. Testing. Emergency braking. The hydraulic calipers clamp onto the steel discs, slowing down the heavy machine, and stopping it in the B of an eye. A true masterpiece of handcrafted engineering, the hubless 3-wheeled motorcycle breaks all limits.